Okay, welcome back, students. Let's continue on. Let's start with chapter 9. I'll get into chapter 9 here with section 9.1. Okay, 9.1 is on first order linear systems. Okay, we showed in 7.3, we used diagonalization to solve one method of solving for first order linear systems. And this 9.1, we're going to show a separate method. Okay, using operators. Okay, definition. A system of differential equations of the form x prime 1 of t equals a11 of t times x1 of t plus a12 of t times x2 of t plus dot 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 plus a1n of t xn of t okay plus b1 of t. Okay, so we have a first order linear differential equation in terms of t. And then we have another one, x prime 2 of t is equal to a21 of t, x1 of t plus a22 of t, x2 of t, plus dot dot dot, plus a2n of t, xn of t, plus b2 of t. Okay, so I have two differential equations, x1 prime, x2 prime. Okay, we could continue this system, okay, for however many variables we have. Okay, we could have x n prime of t equals an1 of t x1 of t plus a n2 of t x2 of t plus dot 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 plus a n of t xn of t plus bn of t. Okay, where aij of t and bit are specified functions on an interval I Okay, so a system of differential equations of this form, okay, is called a first order linear system. If b1 of t or b1 equals b2 equals dot 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 equals Bn equals 0, then the system is homogeneous. Or homogeneous. Otherwise, it is non-homogeneous. Okay. Okay, the solution to a first order linear system of differential equations consists of functions x1 of t, x2 of t to xn of t, which when substituted into the system yield the same result for all t in I. Okay, so let's do an example. We're going to use operators, differential operators, to help us solve an equation. Okay. Number one, solve the initial value problem okay. X prime of 1 equals x1 plus 2x2. X prime of 2 equals 2x1 minus 2x2. x1 at 0 is equal to 1, and x2 at 0 is equal to 0. Okay. Okay, so I'm going to set these up so that I'm going to move everything, okay, to the other side here. And I'm going to get x prime 1 minus x1 minus 2x2 is equal to 0. Okay, and then I'm going to do the same thing with this guy over here. I'm going to say negative 2x1 plus 2x2. Oops, actually, I want the differential to go next. Plus x prime 2 plus 2x2 is equal to 0. Okay, nice. So the bi here, the b is just 0. Okay, because it's equal to 0. They're homogeneous. Okay. So I'm going to rewrite this guy in terms of differential operators. I'm going to say that this is d minus 1 of x1 minus 2x2 is equal to 0. Okay. And then I'm going to write this guy over here as negative 2x1 plus d plus 2 of x2 is equal to 0. Okay, and now I'm going to solve this as if it was just a normal system of equations. Okay, so let's see what we can do here. Let's, I'm gonna bring this underneath. Okay, I'm gonna move that over there. I'm gonna say that negative 2x1 plus d plus 2 of x2 is equal to 0. So now I'm going to use a process of elimination to eliminate one of these variables. I'm going to eliminate x2. So what I'm going to need to do is I'm going to need to multiply the top one here by d plus 2. I'm going to need to multiply the bottom one here by 2. So I get opposites for x2. Oops. Okay, and I could do the same thing to the other side, but it doesn't do anything because it's just going to end up 0. Okay, so this becomes d plus 2 times d minus 1 times x1 minus 2 times d plus 2 times x2 is equal to 0. Okay. And then this guy here is going to become negative 4 x1 plus 2 d plus 2 x2 is equal to 0. And I'm going to add and cancel out the second terms. So this becomes d plus 2 times d minus 1 minus 4 times x1 is equal to 0. Okay, so let me multiply this out. This is going to become d squared, okay, minus d plus 2d minus 2 minus 4 times x1 is equal to 0. This becomes d squared plus d minus 6 times x1 is equal to 0. Okay, now I'm going to factor this guy. So he factors into d plus 3, d minus 2, x1 equals 0. Now I'm going to use my polynomial auxiliary function here. So this is p of r is equal to r plus 3 times r minus 2 is equal to 0. Okay, and so we know that r is equal to negative 3. I'll call this r1 and r2. Okay, r1 is negative 3. And r2 is equal to 2. Okay, so I know that x1 is equal to c1 e to the negative 3t plus c2 e to the 2t. Okay. Okay, so I have x1. What I'd like to get is x2 now. Okay, because x1 and x2 are going to help give me my general solution. Okay, what is x1? What is x2? Okay, well, I can go back to one of my original equations, that being this guy here. And I can use the fact that I have x1. I can take the derivative of x1 to find x1 prime. And then I can solve this equation for x2 and get x2. So that's the general procedure. Okay, we know x1. We're going to take the derivative of x1 to find x prime 1 and then solve for x2. Let me move that guy down here. Okay, so we have x one prime is equal to x1 plus 2x2. Okay, that was one of my original equations. Okay. So what is x prime? Okay, x prime is equal to negative 3c1 e to the negative 3t plus 2c2, that's x1 prime, plus 2c2 e to the 2t. Okay. So I could take this guy here. Now that I have x1 and x1 prime, I could solve for x2. Okay, so well, let's just plug them in. Okay, and then we'll solve for x2 in a second. So this is going to be negative 3c1 e to the negative 3t plus 2c2 e to the 2t, okay, is equal to the original, which is c1 e to the 3t, negative 3t, plus c2 e to the 2t plus 2x2, okay? So now I'm going to combine some like terms here. I'm going to subtract c1 e to the negative 3t, and I'm going to subtract c2 e to the 2t. Okay, so this becomes negative 4c1 e to the negative 3t plus c2 e to the 2t equals 2x2. Now I'm going to solve for x2. Divide by 2, divide by 2, divide by 2. Okay, so x2 is going to equal negative 2c1 e to the negative 3t plus 1/2 c2 e to the 2t. Okay, so I have my x1 and I have my x2. Okay, and that's going to give me a general solution. So general solution is going to be two equations because this is a system of differential equations. The general solution is going to be x1 equals c1 e to the negative 3t plus c2 e to the 2t. Okay, and then x2 is equal to negative 2c1 e to the 3t plus 1/2 c2 e to the 2t. Okay, so that's my general solution. Okay, what about my particular solution? Well, I know that x1 naught is equal to 1 and x2 naught is equal to 0. Okay, so I can use that to figure out what c2 and c1 are. Okay, if I plug in x1, so x1 of 0 is equal to c1 e to the 0, which is just going to be 1, plus c2 e to the 0. And that's going to go to 1. Okay. And that is equal to 1. So I have c1 plus c2 is equal to 1. Okay. And then if we plug in x2 is equal to 0, okay, this is going to give me negative 2c1 e to the 3 times 0 plus 1/2 C2 e to the 2 times 0 is equal to 1. I'm sorry, it's not. It's equal to 0. My bad. Equal to 0. Okay. So this is the e to the 0 powers are just going to go to 1. So this gives me negative 2c1 plus 1/2 c2 is equal to 0. Yeah. Okay, so I could set up a system of equations if I want to. Okay, I could move this guy over here. This would be c1 plus c2 is equal to 1. I could multiply the bottom through by 2. And that would give me negative 2c1 plus 1/2 c2 equals 0. 2c1 plus 2c2 is equal to 1. Those cancel when I add. This becomes 5/2. K is equal to, oh, this is a 2, I'm sorry. There's a 2 there. Okay, is equal to 2. 5/2 C2 is equal to 2. So C2 is equal to 4/5. Okay. And what do I know about C2 and C1? They have to add up to 1. So that would make C1 1/5. Okay. So C1 and C2 have to add up to 1. So my particular solution is going to be x1 equals 1/5 e to the negative 3t plus 4/5 e to the 2t. Okay, and x2 is equal to negative 2, so that's negative 2/5. Negative 2/5 times e to the negative 3t plus, and then this is going to be 4/5 times 1/2, which is 4/5 times 1/2, which is 2/5 e to the 2t. Okay, and that's my particular solution. Okay, so we got the general solution and the particular solution. Okay. But we're really just using those differential operators to set up a system of equations. Okay, that's how we deal with a homogeneous system of equations. Let's try to see what we can do for a non-homogeneous system. Okay, problem number 2. Okay, solve the non-homogeneous system. I guess this doesn't have a hyphen. Okay, x1 prime is equal to x1 plus x2 plus e to the 2t. And x2 prime is equal to 3x1 minus x2 plus 5e to the 2t. Okay, so we have this system of equations. Okay, so now let's toss all the x1s and x2s to the other side. I get x1 prime minus x1 minus x2 is equal to e to the 2t. And then over here, I get negative 3x1 plus x2 prime minus x2 is equal to 5e to the 2t. So now I have that b term from the definition. Okay, b1 is e to the 2t, b2 is 5e to the 2t. Okay, so now I'm gonna use some differential operators here. So this guy here is going to be d minus 1 minus x2 is equal to e to the 2t. Okay, and then I'm going to move this, well, let's do this one. Negative 3x1 plus d minus 1. Is that a minus or a plus? That's a plus, I'm sorry. Yeah, that's a plus. Okay, d plus 1 x2 is equal to 5e to the 2t. Okay, so now I'm going to bring this guy over here. I get negative 3 x1 negative 3x1 plus d plus 1 x2 equals 5e to the 2t. There we go. Okay, so now to get opposites here, what I'm going to do is I'm going to multiply the top one through by d minus 1, or d plus 1, sorry. Okay, so what I get is I get d plus 1 times d minus 1, bring this guy down, there we go. Okay, minus d plus 1 x2 is equal to plus 1 of e to the 2t. Okay, we'll see in a moment how we deal with that. Okay, and then this is, oh, there's an x1 here. I keep forgetting my x1s and x2s. There we go. And this is negative 3x1 plus d plus 1 x2 is equal to 5 e to the 2t. Okay, and then we're just going to cancel out that middle term, that second term there in each of those. And I get d plus 1 times d minus 1 minus 3 times x1 is equal to d plus 1 e to the 2t plus 5 e to the 2t. Yeah, after we add them together. Okay, so let's talk about this guy here. What does this mean? D plus 1 e to the 2t. That means that I'm taking the derivative, okay, of e to the 2t plus itself. Okay, that's what it means. The derivative of e to the 2t plus itself. What is the derivative of e to 2t? Well, it's just 2e to the 2t. So this is 2e to the 2t plus itself, which is e to the 2t plus 5e to the 2t on that side. Let's multiply this out and combine. This is going to be d squared minus d plus d minus 1 minus 3 x1. Okay. The left side is all going to combine into d squared minus 4. And the right side is all going to combine into 8e to the 2t. Okay. So this becomes d minus 2 d plus 2 x1 is equal to 8e to the 2t. Okay. So our variable is just x1 at this point. Okay. You know, that we're taking all these derivatives of, and then it's equal to that. So this is a non-homogeneous. Okay, so when we had non-homogeneous, what do? Well, we actually solved the homogeneous. Okay, and then we used an annihilator to help us figure out what the particular portion is. We need the complementary, and we need the particular portion. Okay, complementary portion and the particular portion. Okay, so let's figure out this guy. Okay, very similar to what we've done in chapter 8. It's just instead of having a y here, that's the derivative. That's the derivative of with respect to t. It's x1 that we're taking all these derivatives with respect to t. Okay, but our auxiliary equation is just going to be p of r, okay, is equal to r minus 2 times r plus 2 is equal to 0. We're going to first solve the non-homogeneous to give me the complementary function. Okay, this means that R1 is equal to -2, and R1 is equal, and R2 is equal to 2. Let me do this. Let's 2 and R2 is -2. So we know that x1 complementary, okay, is equal to c1 e to the 2t plus c2 e to the -2t. Okay. Okay, we know that our function f of t is equal to 8 e to the 2t. So I need my annihilator. Okay, AD is going to be equal to, okay, this is e to the 2t, so that's d minus 2. Okay, for my annihilator. So I'm going to plug that back in to my equation, and I get d minus 2 times d minus 2 times d plus 2 on x1 is equal to 8 e to the 2t. It's not anymore. Okay, we annihilated it, so it goes to 0. Okay. But we have d minus 2 times d minus 2, which gives me d minus 2 squared. So this has a multiple root of 2. It has multiplicity 2. Okay, d plus 2, x1 equals 0. Okay, so multiplicity 2 just tells me that for my x1p, I have to take both cases for this root of 2. Okay, so x1p, okay, is going to be equal to, okay, I have to go up. Okay, a notch here. Okay, so instead of a naught e to the 2t, it's a naught t e to the 2t. Okay, for that annihilator. Okay, that particular solution then. Okay, which makes sense because my complementary function has e to the 2t already. So if my particular solution had an e to the 2t, I would just combine it with that one, okay, to form a different constant. Okay, so we're going to go up a power of t, okay, for a particular solution. Okay, so now we have x1 of p. In our original equations, we can now use this one to solve for x2, because we can take the derivative of x1, solve for x2, and then but first we need to get our particular solution. So what's our particular solution here going to be? Well, okay, x1 prime of p is going to be equal to 2a naught t. Let's do, I'm kind of doing it backwards. Let's do a naught e to the 2t plus 2 a naught t e to the 2t. Okay. Okay. Okay, and the original one had a d squared, right? So we're actually not using that yet. We're going back to this guy here. We're gonna go back right here first, where we actually have a d squared minus 4x1. Okay, that differential equation there. Okay, equals 8e to the negative 2t. Okay, so this has a second order differential equation. So let's go and get our second derivative now. X1 of p is equal to, derivative of that is just 2a naught e to the 2t plus, this is going to be 2a naught e to the 2t plus 4a naught t e to the 2t. So that's going to be equal to 4a naught e to the 2t plus 4a naught t e to the 2t. Okay, and the equation we're going to be working with is this one. Okay, x1 is equal to 8e to the 2t. Okay, and so I know that the second derivative of 4a naught e to the 2t plus 4a naught t e to the 2t. Okay, that's the second derivative of x1 minus 4 times just whatever x1 was. Well, that was just a naught t e to the 2t is equal to 8 e to the 2t. Okay. And so this is, these two cancel. And I'm left with 4a naught e to the 2t equals 8 e to the 2t. Divide by 4, divide by 2t. We get a naught is equal to 2. Okay, so my particular solution, okay, is x1p is equal to 2t e to the 2t. Okay, so that's x1p. So what was our x1c? My x1c was c1 e to the 2t plus c2 e to the negative 2t. So let's plug this all together. So x1 of t is equal to, we'll just call that x1 right now. x1 is equal to c1 e to the 2t plus c2 e to the negative 2t plus 2t e to the 2t. Okay. So now we can go back to that original equation. I'm going to rewrite that one. Okay, x1 prime plus x1 plus x2 plus e to the 2t. Okay, x1 prime is equal to x1 plus x2 plus e to the 2t. Okay. So I want to solve for x2. That's the goal here, is to get x2 by itself. So x2 is equal to x1 prime minus x1 minus e to the 2t. Okay, that's x2. But what is x1 prime? We know what x1 is, but what's x1 prime? Maybe I'll put it right below it. X1 prime is going to be 2c1 e to the 2t minus 2c2 e to the 2t plus 2e to the 2t plus 4t e to the 2t. Okay. I can plug in x1 prime and x1 into this last equation here. And I get x2 is equal to x1 prime, which was 2c1 e to the 2t minus 2c2 e to the 2t plus 2 e to the 2t plus 4t e to the 2t minus x1, which is right above it, c1 e to the 2t plus c2 e to the negative 2t plus 2t e to the 2t minus e to the 2t. Okay, this is going to be x2. So this is going to be equal to 2c1 e to the 2t minus 2c2 e to the 2t plus 2e to the 2t plus 4t e to the 2t minus c1 e to the 2t minus c2 e to the 2t c2 e to the negative 2t minus 2t e to the 2t minus e to the 2t. Okay, and so let's combine some like terms. So that can combine, and that can combine. Okay, and this can combine, and that can combine. So this is going to be equal to x2 is equal to 2 minus 1 is 1, c1 e to the 2t. Negative 2 and negative 1 is negative 3, c2 e to the 2t. Okay, the 2 e to the t, that's just minus easy. I'm going to put that last. 4t minus 2t, 4t minus 2t is 2t, e to the 2t, and then this is 2 e to the t minus e to the t is just plus e to the 2t. Okay, so that's x2. Okay, so we know what x1 was. Oops. We know what x1 is, and we now know what x2 is. Okay, I probably just factored the e to the 2t out of that, but x2 equals c1 e to the 2t minus 3 c2 e to the, that should be a negative, right? I drop all my negatives here. Oops. That's a negative. That's a negative. That's a negative. Negative, there we go. Okay, negative t, 2t, and then this is going to be plus e to the 2t times 2t plus 1. Okay, so now we know what x2 is, and that's going to be our solution to our general solution. Okay, so we're going to say that our general solution is x1 equals c1 e to the 2t plus c2 e to the negative 2t plus C2, yep, e to the negative 2t, plus 2t e to the 2t, that's x1, comma, okay, x2 equaling c1 e to the 2t minus 3 c2 e to the negative 2t plus e to the 2t times 2t plus 1. Okay, and this is my general solution. Okay. Okay, that is 9.1, and I will see you in the next section.